Imagine this, your phone, the laptop you work on, the electric car in your driveway. Now think bigger. A wind turbine turning silently on a hill, a fire jet streaking across the sky, even some advanced cancer treatments. All of them depend on the same small family of 17 strange elements that most people can't even name. But here's the twist. They're called rare earths, and they're not actually rare. Yet a single country controls almost the entire global supply chain, and without them, modern life doesn't just slow down, it grinds to a halt. This is the story of the hidden metals that power our future. First, let's clear something up. Rare earths is a terrible name. They're not rare, and they're not earths. They're a group of 17 metallic elements with tongue-twisting names like neodymium, dysprosium, and europium. You won't find them in big, shiny chunks of metal. They're spread thin, mixed into other rocks, stuck to other metals, and often tangled up with radioactive elements like uranium and thorium. Getting them out of the ground isn't the hard part. Separating them from everything else is. That process is incredibly expensive, chemically messy, and highly polluting.
So why bother? Because rare earths are like industrial superpowers. Add just a tiny amount of one to a product, and suddenly that technology becomes brighter, faster, stronger, and more efficient. You're surrounded by these superpowers every single day. The motor in an electric vehicle, the generator inside a massive wind turbine, they run on powerful magnets made from rare earth. The tiny speakers in your headphones, the hard drive in your computer, the vibrant colors on your smartphone screen, the precision of an MRI machine, all enabled by these elements. But the applications get much more serious. They're in missile guidance systems. A single F-35 fighter jet contains hundreds of kilograms of rare earth materials. A Virginia-class nuclear submarine uses thousands. The common thread in much of this is magnetism. Elements like neodymium and dysprosium create the strongest permanent magnets known to man. These magnets are the workhorses of high technology, from robotics to the most sensitive military hardware. Rare earths don't just power our gadgets, they power national security. So, who controls this critical resource? While many countries have rare earth deposits underground, that's not what matters. The real power isn't in who has the rocks, but in who can process them at scale.
And processing is a dirty business. It creates radioactive waste and requires a complex, pollutant chemical separation process. Back in the 1980s, the US and other Western countries did this work. But as environmental rules got stricter, the plants closed down. China did the exact opposite. It invested heavily, scaled up production, accepted the pollution, and built the entire global supply chain from mine to magnet. The result? Today, around 90% of all rare earth processing happens in China. One mine in Inner Mongolia, Bayan Obo, is the largest on the planet. Satellite images show enormous open pits next to vast toxic lakes of chemical waste. For every ton of rare earths produced, thousands of tons of waste are left behind. The world wanted cheap, green technology. China was willing to supply it, and the environmental cost stayed local. A cost hidden inside every device we can't live without. Whenever one country controls something the entire world needs, it inevitably becomes a strategic weapon. That's exactly what happened with rare earths. Picture this. It's 2010. Tensions are flaring between China and Japan over a territorial dispute. And then, abruptly, China cuts off its rare earth exports to Japan. Instantly, prices for these crucial metals skyrocket. Panic rips through factory floors, and the world has a sudden cold realization. This supply chain, it can be turned off, just like a tap. Now, fast forward through the last decade to the constant hum of today's US-China tensions. We see the headlines about tariffs, sanctions, the chip war, the frantic reshuffling of supply chains. But behind all of it is one quiet, powerful truth. Rare earths determine who can build the next generation of technology, and they determine it in ways most people never even think about. So the natural question is, are we about to run out? The answer, surprisingly, is no. The Earth's crust has plenty of these deposits. But we are running out of is something else entirely: easy deposits, cheap deposits. We're running out of clean ways to process them. And most importantly, geopolitically simple supply chains. If the world is serious about having millions of new EVs on the road, expanding wind power, building better medical tech, and developing advanced defense systems, we need new ways to get these elements. So, a global race is on. First, there's the traditional approach, new mines. Countries like the US, Canada, Australia, and nations across Europe are scrambling to open them. The problem? A new mine can take 10 to 20 years to become fully productive. A second, more clever approach is gaining ground, urban mining. This is the science of pulling rare earths directly from our mountains of e-waste, from old smartphones, discarded motors, and even entire landfills. It's already happening, it just needs to be done at a scale. But the most futuristic solution is biotechnology. Scientists are engineering bacteria and proteins that act like tiny metal magnets, specifically designed to grab rare earth elements from industrial waste. It's still early days, but the promise is enormous.
If we can make these methods work, rare earth production could become cleaner, more diverse, and far less dependent on the decisions of any single country. So why does What If Money care so much about rocks? Because rare earths expose a fundamental truth that most people forget. The financial future isn't built on purely digital ideas, it's built on physical materials. Behind every electric vehicle, every semiconductor chip, every massive wind turbine and data center, behind every satellite and national defense system are metals like these. You literally can't swipe a credit card without the copper in the wires, the silicone in the chips, and the rare earths in the tiny motors and sensors that make the transaction possible. If oil was the black gold of the 20th century, powering our industries and shaping geopolitics, then rare earths are quickly becoming the gray gold of the 21st. Not because they sit in your wallet, but because they determine, quietly but completely, who wins the future of technology. The next time you scroll on your phone, drive past a wind farm, or watch an EV glide silently by, remember what's hidden inside. Remember that there are 17 strange elements in there, often mined from toxic pits, refined in enormous factories, and now fought over by the world's biggest powers. This isn't investment advice. This is about understanding the hidden machinery that powers modern life. Because the future may feel electric and digital, but it still begins with rocks. Thanks for listening to What If Money. Subscribe for more hidden stories behind the systems that shape our world.